Okay guys, welcome to the Chapter 6 homework videos. Now Chapter 6, if you no doubt have figured out by now, is all about bonds and interest rates, mostly about bonds. Now since it's the first problem, we'll talk a little bit about bonds before we just jump in and trying to solve the problem, because bonds in their simple form, which is all we're going to consider in this class, in their basic form, are a very simple financial instrument. Okay? It's just a simple interest-only loan. Okay, this is one way at least that corporations borrow money, and it's one of the ways the U.S. government borrows money as well, by issuing bonds. Now, if you issue a bond, what you do is you receive some payment up front. Someone purchases the bond from you, and it's an interest-only loan. So what happens is you agree to make semi-annual payments, interest payments that only cover the interest on the bond for however many years until the bond matures, which is defined in the contract. If it's a long-term bond, it's usually something like 30 years. So you make payments every 6 months to whoever owns the bond, and that only covers the interest. And then at 30 years, when it matures, if it's a long-term bond, you pay $1,000. And that's standard. Bonds usually have $1,000 face value. 2000s become a little bit popular in the last little while, but still the vast majority of bonds pay back $1,000. Okay? So if we're trying to calculate these things, we've already got all the tools already. If you've studied the Chapter 4 and Chapter 5 material, you've got all the tools you need to be able to find whatever I can ask you about these bonds. As if we think about a bond, we're receiving a level payment every 6 months while this thing is out there until it matures. That's nothing but an annuity. And we already know how to find the present value, the payment, the interest rate, the future value of an annuity, everything I might ask you about a bond. The $1,000 that you would receive at the end if you purchased a bond is nothing but a lump sum payment. And that's all Chapter 4 was about, finding present values, future values, interest rates, and everything else about lump sums. So you already have all the tools that you need to be able to calculate these things. Where bonds present a challenge for us is that they are very rich in vocabulary. Okay, we have to learn how to interpret these questions because, as you see here in number 1, it doesn't give you exactly what the payments are. It gives you information about what the payments are, but we have to be able to interpret it. So that's what we're going to talk about, at least on number 1 here with bonds, before we jump into solving the problem. So let's read the problem and talk a little bit about what bonds are and how they work, or at least how the vocabulary works. And number 1 reads that a 5.5% $1,000 bond matures in 7 years, pays interest semi-annually, and has a yield to maturity of 6.23%. What is the current market price of the bond? Okay. What number 1 is telling you here is when it says a 5.5% $1,000 bond, the $1,000 is the face value, or what we also call the par value. Those two are interchangeable. Okay, that's the money that you'll receive at the very end of this thing if you were to purchase the bond. You get a lump sum of $1,000. If we say a 5.5% bond, that introduces a lot of confusion, because what that is the coupon rate. It tells you what the coupon payment is going to be. Okay, that's not the discount rate. Okay, that's not what we're going to use to discount this thing. It's not the interest rate you're going to use to discount it. It is the interest that the bond pays. This bond is going to pay 5.5% each year, is the way it's quoted. This is an annual coupon payment. Okay? The way that you find, what this question tells you is that it pays interest semi-annually, right? So it pays it twice per year. Okay? And the way bonds are quoted is when it says 5.5%, that's the annual coupon payment. So in order for us to find the semi-annual payment that we're going to receive, we need to take the annual payment and divide it by 2. And so that's what step 1 does for us here. We're finding the semi-annual coupon payment. This is the payment that you will receive every 6 months if you were to purchase this bond. Okay? And the way we find the annual payment, we'll start with that and then divide it by 2, is we take this annual coupon rate, and that's always what's going to be quoted in the problem. When it says a 5.5% bond, it doesn't have to tell you that that's an annual rate. That's just the way bonds are quoted, so it'll always be true. Okay? So we take that 5.5% times the face value of the bond. And again, at least in this class, the face value is always assumed to be 1,000, so the problem doesn't even have to tell you that. It could just say a 5.5% bond. You know that 5.5% is the annual coupon rate, and you know that the face value is $1,000 without the problem having to tell you that. We're going to assume those two things are always true. Okay? So in order to find the annual coupon payment, we take that annual coupon rate of 5.5% times the face value of $1,000. So if we go down to the next line, that's what we've got in the numerator here. And then we divide that by 2, because this $55 here that the numerator gives us, that's the annual coupon payment. That's the annual interest that this bond is going to pay us. But it's split up into two payments because it pays semi-annually. So we've got to divide that by 2 to find that every 6 months we're going to receive $27.50 if we were to purchase this bond. Okay, now let's take that and put this on a timeline to clarify a couple of things. One, the way a bond works, and then 2, let's make sure we're on the same page about the semi-annual payments and semi-annual compounding. Okay, so the timeline here shows what we have to do. We want to know the current market price of the bond. Okay, so what we've got are 2 payment streams here. We've got $27.50 that's going to come in every 6 months for 7 years. Okay, so when we draw the time on our timeline, we're going to go out to 14 is going to be the last coupon payment we receive. And then we get that 14 is we take the 7 years times 2, because this thing pays semi-annually 2 times per year. So after 7 years, we'll receive 14 payments of this $27.50. Okay, with the first one happening 6 months from now. All right, one semi-annual from now. Okay, so we've got this stream, this $27.50, every 6 months, all the way out to 14. We receive 14 of them. Okay, that's like an annuity, just like we did in Chapter 5. All right, and all we want to do is take each one of these and discount it back to time period 0, so we get the present value of it. And that's what the price of this is going to be. Okay, but then at the end, we not only receive that final coupon payment of $27.50 at the end of 7 years, but we also receive $1,000. We get the face value back. Okay, so we not only have this annuity we need to find the present value of, but we also have the face value of $1,000, this lump sum right here we're going to receive at the end of 7 years. Okay, we need to take that and also discount it back to time period 0. Okay, so this is broken down into 2 pieces. If you read the text, there's a formula you can use as well, where you just add together the present value of the annuity, which is the interest payment streams, the coupon payments you'll receive, plus the lump sum. You find the present value of the lump sum of $1,000 here. But thankfully, our calculator can take care of all of that for us. Since we have a level payment stream with just one lump sum out at the end of it here, we can use the time value keys on our calculator, and we don't even have to go into the cash flow menu or anything like that, although you can use that if you want to. And but the time value keys take care of this very cleanly for us. 2 things we have to be careful of using the time value keys with bonds, though. It's the semi-annual coupon payment that's going to get us. So when you plug in, although this bond matures in 7 years, we're going to receive 14 payments because we get paid every 6 months. Okay, so when we enter in, we always have to multiply the number of years by 2. That's going to be true for every bond that we look at in this homework and in this class. We're always going to assume semi-annual compounding and semi-annual payments. Okay, so in here is 14, and that comes from the 7 years times 2. The other thing that will get us is the interest rate here. Okay, what we're going to use for our discount rate is yield to maturity. With the bonds, yield to maturity is our discount rate. It's the actual yield that we'll receive on the bond, our rate of return on the bond. So remember we talked about the discount rate a couple of chapters ago, that little R in the earlier formulas. We gave it a lot of names. We talked about the required rate of return. It was the, I don't think we talked about cost of capital, but it was our discount rate, our interest rate, all of those things. Yield to maturity is that thing. It's another name for it with bonds. It's what we're going to use to discount these payments. Okay? But the problem tells us that the yield to maturity is 6.23% for this bond. That's our discount rate. That's what we're going to plug into I over Y. But we have semi-annual compounding with bonds, and we're always going to have that with every bond. Okay? So you've always got to take your the yield to maturity that you're given and divide it by 2 to get your actual interest rate of 3.115. Okay? So that's the I over Y we're going to plug in. Present value is what we're looking for. Okay? So we're going to skip over that. And then our payment here is $27.50 and our future value is $1,000. And before I start plugging this into the calculator, another word of warning when we're using the time value keys. Up until now, there's been a problem or two where we had to be really careful about what we made a positive and what we made a negative when we were putting numbers into our time value keys in the calculator. With bonds, it's very, very important that we pick a perspective and stick with it. Because if we put if we assign a negative sign in the wrong place when we're putting these in here, we're either going to get an error 5, that message that says we messed up with the negative sign, or we're going to flat out get a very, very wrong answer. It may do the calculation because we entered it just right, but we'll get a very, very wrong answer. So with bonds, make sure you pick a perspective and stay consistent with it when you're thinking about cash flows and whether they're positive or negative. As always, I'm going to pick the perspective of myself, money coming into and out of my pocket. Anything that's coming out of my pocket is going to be a cash outflow or a negative. Anything going into my pocket is going to be a positive. That's a cash inflow for me. So for this bond, I'm going to assume that I am buying it. Okay, so if I buy it, my present value is going to turn out negative because I'm going to take money out of my pocket to purchase it today. Okay, so that when we calculate it, that's going to come back negative. But for the payment, I'm going to receive this payment of $27.50 every 6 months. That's going to be a positive cash flow to me, and it's going to go right in my pocket. Okay, the future value that I receive at the end of 7 years is also a positive cash flow to me. Okay, that's money that's going to come to me and go into my pocket at the end of 7 years. Okay, so let's plug everything in and see what happens now. So I'll do 14 is in. Okay, I'm going to do 6.23 divided by 2 equals. Okay, and I get that 3.115. Now I'm going to press the I over Y key. Okay, so it stores it for my discount rate. Present value I'm going to skip over. That's what we're looking for. Payment is 27.5, and then I'll press the payment key to store it in there. And then future value is $1,000. So 1,000, then future value. All right, now I can compute present value. Okay, and you'll see that minus 95909. Okay, so the way to interpret that is the current market price of the bond. That's what we should be willing to pay. We should be willing to pay the $959.09 in order to receive this future flow of cash, these future cash streams, the $27.50 every 6 months, and then finally the $1,000 at the end of 7 years. Okay?